All right, so this video is about, again, solving systems of equations by substitution, but looking at the possibility that we might get no solution or that we might get infinitely many solutions. So we're going to solve a system of equations and receive no solutions, and then a system of equations and have it have infinitely many solutions. So let's start solving it the same way. So when we solve a system of equations by substitution, we have our two equations. And we make, this says y equals, so we can plug it into this equation. So we have negative 4x plus 18 equals, so that's this part being substituted here. And then this expression on the other side, negative 4x minus 6. Now, we want to get rid of a variable, so all our variables are on one side, but when we try to do that, oops, 4x, I don't know why I put 46, we have to add the same to the other side, and we can see that negative 4x plus 4x is 0, and here negative 4x plus 4x is 0. So in this case, we end up with 18 on the left side of our equation and negative 6 on the right. So there are no x's left to solve for. So similar to when we were solving equations in one variable, when the variables are gone and we have a false statement, 18 is not negative 6. So we get this false statement. This tells us that there is no solution. But we should think about how it is that we have two lines, right, graphed on the same coordinate plane and we get no solution. So let's graph them and see what it means that there's no solution. So let's graph them. So here I have a y-intercept of negative 6, and that goes down 4, right 1. So that's this line. That's not 4. There we go. It's a close call. So this is our line, our first equation. And then when we graph that other equation, we're up here at 18, which is off my graph. So let's say if we were at 18 and we went down 4, 14, down 4 again to 10, we would have gone over 2. So that's going to be coming through here and down 4, right 1, down 4, right 1. So we can see that these lines are moving in the same direction because they have the same slope, which means they will never cross. They're parallel. So these lines are parallel. They'll never cross. That's why the system has no solution. So if we go back to our original equations, we can see that right away we can see that if we have the same slope, and if we have different y-intercepts, so notice our slopes match, but our y-intercepts are different, this will lead to no solution to the system of equation. So then let's look at the alternative to that, which would be infinitely many solutions. So here we have two equations and we can tell right away that they're exactly the same. So y equals negative 3x plus 8, y equals negative 3x plus 8. So this is when we're going to have infinitely many solutions. So again, we make our substitution. Let's see what happens algebraically when we do this calculation here. So again, y equals, I substituted in here. So I have negative 3x plus 8 equals negative 3x plus 8. And again, hopefully we'll see a pattern here and we could skip all of this and not even start all this process because we'd know right away there were infinitely many solutions. So the 3x and negative 3x cancel, 3x and negative 3x cancel. So here, unlike when we had no solution and we had a false statement, here we have a true statement. 8 is 8. So that's a true statement, but again, no variables. So this tells us, when we have this true statement here, this tells us that we'll have infinitely many solutions. And in terms of a system of equations, that means that every point is the solution. Or you can just say infinite solutions. Infinite number of solutions is also okay. So if we graph this, what we will see is, so let's come over to the graph here. We see we have a y-intercept of 8. We go down 3, right 1, down 3, right 1. So this is our line. And then when I graph the second line, I would do exactly the same thing. I would go to y-intercept of 8. I would go down. So we would have another line right over the top of this line. So we can see infinitely many solutions because they touch at every point. Every point is a point of intersection. Every point is a solution. So we can generalize this to say that if we have same slope in each equation, or same slopes, and same y-intercepts, or you could also just say if they're exactly the same equation, then we would have an infinite number of solutions. So when we're solving systems of equations with two linear equations like this, we have the possibility of one solution, which we've seen lots of examples of previously. And in this case, we also have the possibility of no solution when the lines are parallel, and infinitely many solutions when the lines coincide, we say. When they coincide, meaning they're the same line. They're right on top of each other.